discussing is multiple linear regression. In the last video, we discussed simple linear regression, where you had one independent variable and one dependent variable. In multiple linear regression, you have two or more independent variables and one dependent variable. And so what we're going to do is we're going to demonstrate multiple linear regression by writing a program in Python to do it. And before we write our program in Python, what we have to do is we have to import some libraries to help us to execute the program. So the first library that we're going to import is NumPy as NP, which is a numeric library. And then we're going to import matplotlib.pyplot as PLT, which is a visualization library. And we're going to import another library from MPL underscore toolkits underscore mplot3d, import axis 3D, which also helps with visualization. It's a more complex visualization. And then from sklearn.linearmodel, we're going to import linear regression, which is the machine learning aspect of this program. So although linear regression is considered machine learning, at one time before they had machine learning, linear regression was part of statistics. So you can find the linear regression model in Python statistical library stats modules as well. But people like to use sklearn because it's easier to use than stats models. I think that the documentation for sklearn is a lot more comprehensive than the documentation for stats models, or that's what I've been found to be the case anyway. If there's not really concise documentation in stats models, and then you have to kind of like try to figure out what you're doing. But in sklearn, it's so much easier to use, and I think that's why people decide to use it. So what we want to do is we want to set up our sample data of our study hours and attendance versus test scores. So your independent variables are going to be study hours and attendance, and your test scores are going to be your dependent variable. So your study hours is a NumPy array from 1 to 8, and your attendance rate is a NumPy array from 60 to 95 in 5-point increments. And your dependent variable is your test scores, is a NumPy array from 50 to 85 in different increments. So we're going to combine the independent variables into a 2D array. So x equals np dot column stack bracket study hours comma attendance rate. And so what that does is that combines the study hours and attendance rate into a 2-dimensional array. So now we're going to create our model. So we're going to use linear regression model. Model equals linear regression dot fit brackets x comma test scores. And then we're going to predict on those test scores. So predicted models equals model.predictx. And then what we're going to do is we're going to print the regression coefficients and also the score. So we're going to print coefficients, the intercept, and the score. So your coefficient slope is 0.183 and 0.918. Your intercept is -5.60, and your score is 0.99. And we're going to make a graph of this, but you can see that your blue dot is your actual data, and your regression line is a plane. So, and it shows the actual data across the regression plane. But we're going to go ahead and give you the code to actually visualize the data. So we're going to visualize the 3D scatter plot and regression plane. Fig equals plt.figure brackets fig size equals 6,4. AX equals fig dot add subplot brackets 111, comma projection equals 3D. And we're going to plot the actual data points. AX dot scatter brackets study hours, comma attendance rate, comma test scores, comma color equals blue, comma label equals actual data, comma alpha equals 0.8. And then we're going to generate a mesh grid for the regression plane. X1, comma X2 equals np.meshGrid brackets np.linspace brackets min study hours, comma max study hours, comma 10, comma np.linspace brackets min attendance rate, comma max attendance rate, comma 10 brackets. Z equals model.intercept underscore plus model.coef underscore 0 times x1 plus model.coef underscore 1 times x2. And we're going to plot the regression plane. AX dot plot underscore surface brackets x1 comma x2 comma z comma alpha equals 0.5 comma color equals red, comma label equals regression plane. Now we're going to add labels and a title to the chart. The title is multiple linear regression, test scores prediction, study hours is X label, Y label is attendance rate, and Z label is test scores. You get a legend, and then we're going to show it. But before we show it, I just wanted to show you that the score was 99%. So that meant that your accuracy of the score, the accuracy of the prediction was 99%. And you can see that it was 99% because the actual data fits on the regression plane quite nice. And so this is a 3D chart, and that's just another example of the kind of charts that you can make using Matplotlib. I mean, most of the other charts that we have made have been 2D, but if you really want to get into it, you can also make 3D charts as well, and this is an example of a 3D chart. So that concludes this video. The next video, we're going to be talking about nonlinear regression. So I hope you decide to watch it.